Okay. All right. So Jordan in Tobago sent me this paper. Asked me to do this paper for him, which is the Pure Maths June 2021, paper 1, the multiple choice paper. All right, so I'm just gonna run through it now. I have Brandon with me online. Brandon has joined me to go through this paper. You know that we need to get full marks on this, on the multiple choice, because the person said that some challenges on the paper 2, in particular, in the 3rd module. Right? I think it was a very nice paper. But then I have the years of experience, so I will always think that. And I like challenging questions. I like questions that could cause, of course, you just to think outside the box, and find that some of the questions were like on that paper. And I also noticed a difference in the structure or the setup of the paper. For example, there were a lot of vectors questions in there. Usually for the Pure Maths, it used to be just a little small amount of vectors, And I find that they're setting looks like they're going to be setting some of the higher level vectors questions going forward. In the past, it was just really some of the most basic vectors questions. So hope teachers will prepare the students for that. All right, so let's go through this paper. That's what I'm doing it for Jordan, but everybody else can benefit from it. And Brandon is here with me. So Brandon can ask questions, if there's anything. All right. All right. Remember, I always say to the students, the answer is on the paper, Sometimes the question look challenging to you. Any question look challenging to you. The answers are right there. You can use a process of elimination and arrive at the correct answer. All right. All right. So this question says, given that x and y are negative integers and the x is actually greater than the y, which of the following is true? Which of the following is true? Well, this can be confusing a bit. And sometimes I prefer to actually have some values looking at. But I can work this as an equation first. I can work this like an equation first. Right? I can set it up this way. So x and y are negative, right? Both of them negative. So watch this now. I'm going to prove one of these using this method. I'm going to transpose this and make it positive first. So I'm going to get x minus y is greater than 0. That means x minus y is greater than 0, positive. Remember, x and y are negative. So if x and y are both negative, that means that x plus y has to be a negative value. Must be negative because they are both negative. So the sum of them must be negative. And so if I'm going to multiply now, this x plus y times this, in other words, I'm multiplying the x plus y times this inequality, I will have to reverse the inequality sign because I'm multiplying with a negative value. When you multiply an inequality with a negative value, you have to reverse the inequality sign. So if I multiply by this, which is a negative value, I will have to reverse this inequality sign. So this is what I would get. I would then get x plus y times x minus y. The sign has to be reversed because I'm multiplying with a negative value, less than 0. And this is the difference of 2 squares now. So this basically reads x squared minus y squared less than 0, which transposes, because these values are on either side of the inequality sign, which transposes to y squared greater than x squared. Which one of them is that? Y squared greater than x squared. So this is the answer. That's a nice way to do it, I think. But then we could also just do it by trying some values. All right. So I'm going to leave this on the screen as a method to do it. All right. And I can do these things again because of my experience. Not everybody's going to just think of maybe doing it that way. But, this method that I've used really is pulled out of the experience I have with other similar questions in the past. That's the benefit of doing a lot of maths. The more maths you do, the more experience you get, the more you can see through questions. It's like when you see a question, you just connect it back to something that you know from before. Watch this now. How can I work this out again? we can basically just use some values, you know. So if x is less, if x is greater than y, and both of them negative, right? It's like I have two negative numbers, -2 and -3. This can be the x, and this can be the y. X is greater than y. And what does that mean in these answers? That they are squaring the values. They're actually squaring them in. So right now, the y is less than x, or the x is greater than y. This way, you can write it this way. So if I square the values, if I square the -3, it's gonna become 9. 9. So that is the y squared, you know. And if I square the -2, it's gonna be 4. That is x squared, you know. 9 is greater than 4. See there? So the inequality must turn that way. See, I get the same answer again. So I could get this by just giving some values. Just giving some values like that. And just put my values on a number line. And remember now that this -3 is actually less than -2. So that's another way we could do it, by just trying values. All right? So I'm going to leave both of them on the screen to show that that's how we could get it, by trying values. All right. This one here now. All right. So if the function of x is the modulus of x. Now, the first thing we need to know is what the modulus of x graph looks like. All right. It basically looks like this. It's like the y equal x, and you reflect the negative part of it. So like you have the y equal x graph going like so. And then this part of it, you reflect it this way. Let me use different colors. This is my y-axis. This is my x-axis. And the modulus of x graph will look like this. That's the modulus of x graph. This is the modulus of x graph. That's how it will look. This now is a transformation of this. What does +2 mean? This +2 means that this graph is shifted 2 units up on the y-axis, because you're adding 2 to all the y values. So if I look at this, the answer is the first one. And this is if this graph right here has to be f of x, because it is the modulus of x +2 you want, you know. So it has to be f of x +2. This first one is the answer. F of x +2. You shift the graph 2 units up on the y-axis. So this is the answer. But let's see what each of them is. So see this one is basically you take this graph and you shift it to the left. The fun thing about it is that when you shift it to the left, the function, the x value in here becomes x -2. No, it becomes x +2. So this is the graph for the modulus of x +2. And for one, you can try values in it. X +2. So when you shift a graph to the left, you increase the x value. If you shift it to the right, it will become x -. Therefore, you can try values on this and try values and see if it works. So for example, when x equal -2, right, you're gonna get 0 in here. So that corresponds to that. What about up here? So that is when it is equal to 0, you know, when the x value is 0. So when the x value is 0, you're gonna get the modulus of 2 squared. The modulus of 2, which is 2. Right? When the x value is 0 right there, that is 2. So it kind of corresponds, right? So that is basically it. And if you give it other values, you'll see. So for example, if you give it a value like, give a value out here on this end to show that it is really true. Over here would be -4. So if this is the modulus of x minus, so it's x +2, I said, right? X +2. That's what it is. And if I plug in the -4 there, I'm going to get the modulus of -2. Modulus of -2 is equal to 2. And so it corresponds to the 2 up here. So these 2 points will be the same. Shift it over a little bit here. This will be -4. Right? And these 2 would have the same y value. But that is a graph. It shows that it is real. It is real. So this is a graph. I'm going to tell you what each of them is. You know. What is this one? This one shift down by 2 units. You see, it was here. and then shift down by 2 units. So this one would be the modulus of x minus 2. Shift it down by 2. And then this is the one now. That would be the modulus of x minus 2 this way. The graph shift to the right. And so you put a negative here. All right, so that would be those graphs. I've written what the other graphs would be. And so in case they give you any one of these in another exam paper instead of the f of x plus 2, then you would know. So for example, I'm telling you, so for example, this one, I'm writing it this way. This one would be f of x minus 2. And this one would be f of x minus 2. See that? And then this one would be f of x plus 2. So if they give you this is the answer. If they give you this is the answer. And if they give you this one, that is the answer. I wrote what they are, each one. All right, so that's it. Next question. Over here. All right. Question says, number 3. Number 3 gives us this proposition. It says, P is Andrew, works all day. He is distracted. He will complete the report. All right. Let's see what they're saying now. It says the expression if, so this is like a conditional statement. Eh? If Andrew works all day, so basically this is a if P, you know, works all day. That's a if P. And is distracted, so this is a conjunction. It is not distracted, so that's a not Q that you know. So that's a and, it's a not Q. This is not Q. So these two form one statement, this and this. Right? Form one statement. So it's really a this and not Q. That's what that first line is. Underline all of it. So the first line here. So it's if this, that's what all of this is. This is a then, you know. He will complete the report. So that if then statement, you know, he will complete the report. He will complete the report. So this is a R. He will complete the report is a R. All right. So basically, it's basically this one is the antecedent and this is a consequent. So you're looking for that. So CTRJ, so this implies that. So this is the answer. Nice and easy. Next one. All right. So if I look at these answers for this, I see I have square root of x, square root of x, square root of x, square root of x, square root of x. So basically, it's quite simple. We want to move the 3 from under that square root there. So we want to simplify this and get rid of this 3. All right. So I'm going to write this back as 4 root x plus this now becomes 4 root 3 root x. I've broken out the root 3 out of here. But then I need to get one of these answers. So I need to simplify down to the lowest terms. We'll start with the 48. I want to get a root 3 in the 48 as well. So I'm going to write the 48 as the square root of 3 times 16. Just like that. Then the square root of 16 is 4. So then this becomes 4 root x plus 4 root 3 times root x over. Then this 60 root of 16 is 4. So I get another 4 root 3 under here. So the 4 root 3 and the 4 root 3 here cancel each other. Put it in there. They cancel each other. This and this cancel. So I'm left with 4 root x plus root x. So that is 5 root x. So that is 5 root x equals 5 root x. So this is my answer right here. A. Easy question. Easy, easy, easy. All right, let's go. I'll finish this quickly now to go and sleep. This one says x minus 1 is a factor of this. Now what is R? If it's a factor, then it means that f of 1 is equal to 0. We're calling this f. Simple as that. F of 1 is a nice number to work. It's like a plugging in 1 for the x values everywhere. And I'll put the result equal 0. So this x to the 6th power becomes 1 minus. This also becomes 5. 1 to the 4th power is 1. This becomes 5 minus. This also becomes 1. So that is 10 plus the r is equal to 0. So what does this work out to? This work out to negative 14 now. But this is 15. Right? And 1 minus 15 is negative 14. The negative 14 go over here and become positive 14. So the r equals positive 14. So the r is positive 14 right here. Easy question. Add maths. That can come and add maths. All right. Finish for page 1. Next page. Next page. All right. This says the contrapositive of if Joma is a minor, then he is rich. All right. Let's set it up. All right. If Jonah is a minor, so we're going to make this the P, then E is rich. Make this be the Q. Now, the conditional statement is P implies Q. That's what we have. The contrapositive would be not Q implies not P. That's the contrapositive of this. We're treating this in this statement. So we're basically looking for this now. Not Q implies not P. So we're looking for if Jomo is not rich, then he is not a minor. That's what we're looking for basically. Let's look for it. If Jono is not rich, then he is a minor. No, that's not it. So we can eliminate this one. Eliminate this one. We'll start with Jomo. So eliminate that one. If Jomo is poor, we're not going to say not poor. We don't know say not rich means poor, right? We have to go with the statement that they gave us. We don't know that not rich means poor, so we can't say that. All right. We have to say not rich. If Jomo is not rich, then he is not a minor. That is the answer. So this is our not Q implies this now is our not P, which is what we wanted. All right. He is not a minor. That is it. So this is the answer right here. This is our answer. And this now putting an arrow on here. So for the blue, this implies that we wanted the contrapositive, which is that thing. So this is our answer right here. Nice and easy. Next one. This one says if f of x is equal to this, then the range of positive values for which f of x is 1 to 1. All right. Positive values they want. So basically, what it is that this will be a quadratic graph normally like this. For it to be 1 to 1, it's like you have to cut it in half. You have to cut it at the turning point here. So and only take the positive side of it. So essentially, you want to find the coordinates of the turning point, right? Of the minimum point. So this is going to complete the square to find. Or you can calculate it, and you can calculate the x value at this point. X value at this point, it's called xt, is minus b over 2a. You know? That's the formula for the x value at the turning point. You can use that instead of completing the square now. So it's going to be greater than it. So it's going to be greater than this. X is going to be greater than this. X is going to be greater than that x value at the turning point. That's what you want. You want x to be greater than the x value at the turning point, or it to be a 1 to 1. When it is red now, it is 1 to 1. So the red one is 1 to 1. 1 to 1. And when we have the entire graph, when we have the entire graph with the blue in here, let's put it over here. It is many to 1. The blue is many to 1, which cannot have an inverse. Many to 1. The blue is many to 1. The many to 1 cannot have an inverse. So when you have a quadratic function, if it's going to have an inverse, you have to restrict the domain and make it a 1 to 1. And one way to do that is to cut off half of the graph. So you restrict the domain. So what is this x value at the turning point? Minus b over 2a. Let's work it out right here. So it becomes bang, bang, boom. It becomes minus, the b is negative 6. So minus negative 6 over 2 times 3. 2 times 3. So that becomes a positive 1. So the answer is x greater than positive 1, which is right. Okay. This is the answer. Right? Taking half of it. I want the positive side. This half of it, if you took this half of it alone, the answer also could be x less than 1, you know. Meaning you're using this half of it instead, which is still 1 to 1. But that's if you wanted the negative values, right? On the left side. If you because I want the positive values, you're going to the right. You don't want to go to the left. But that is it. Right? So it is the red. It is the red part of the graph that is 1 to 1, starting right here. And in fact, we're not even going to put an open circle on the 1 because we're not including the 1. So we're not including the 1. Just on the positive side. The red is 1 to 1, and the blue is many to 1. The make a it's less than here, so it is that. Next one. This one gives us this equation, and it says, what is the sum of the roots? I can know the sum of, if I just divide 5 on a year and write it, it's going to be 2 over 5. I know that, you know, but if you want to use a formula method, then this sum is minus b over a. This sum is minus b over a, which becomes minus a negative 2 over 5, which then is 2 over 5. But I could do it 2 over 5 by looking at it. I'll explain that another time. Another opportunity. Right? That is that. Easy so far. 9 questions gone already. Question easy, paper easy so far. This one says when this thing is divided by x minus t, what is the remainder? So it's in, this is the divisor. The remainder is going to be f of t. Calling this f again. So all of these terms are going to become t to the 4th power now. Look at it. If I plug in t in for the x in each of those. Each of them going to become t to the 4th. Or f of t. Plug in t here, so it becomes t to the 4th. T here, so t to the 4th. T here, so t to the 4th. T here, so t to the 4th. So my list it out is t to the 4th plus t to the 4th plus t to the 4th power plus t to the 4th power. 4 of them. That's what we get. 4 times t to the 4th power. See here? This is the answer. Easy. Easy. Number 9. Only 45 questions on this paper now. I've gone 10 already.
Wait, so you could go over about number 9 again?
Number 9?
Yeah.
Yeah, man. So if you divide by x minus t, the remainder is f of t. Remember, if you divide by x minus 2, the remainder is f of 2, you know, don't it?
Right.
So it's x minus t, so the remainder is f of t. So it means that I'm plugging t in this function everywhere x is. So I plug t also for the x cube. I'm going to get t cubed times t is t to the 4th power. I plug t also for the x. It's going to become t squared times t squared is t to the 4th power again. I plug t also for the x right there. So I'm going to get t cubed times t, which is still t to the 4th. And then this is already t to the 4th. So each of the 4 values become t to the 4th power. And so it's 4 times t to the 4th power. Get it?
Yes, sir.
All right. So that's what this is equal to. Okay. All right. Jordan in Tobago now is minutes to 2. Jordan will be sleeping now. So I'm going to send him a call it to join. So let's send him the video. All right, this question now. Now the funny thing about this question, guys, you know, Brandon, you can use a calculator, you know, because you can't use the calculator in the exam. You can just plug that in a calculator, you know, and see what you're might use. That's what I can't understand about CXC with this paper, you know. They're giving you a question that is totally numerical. And you can put that in a calculator and work it out. I can't understand it. I just can't understand how they allow you to use a calculator and they give you a question like this. That you can just type it in the calculator and get your answer. Let me bring up the calculator and show you. Right? Let me bring up the calculator and show you. You have the calculator that can work out these logs. And even if you have the calculator that can work out log to base 8. You see this right here, so? Log of 18 to base 8 is the same as log to base 10 of 18 over log of 8, you know. If you're working in base 10, you know, by the change of baseline. So if you don't have if your calculator can't put this in, you put this in for it in the calculator, and you're good to go. Right? So let me show you now. Here's my calculator. You can just type this in and get the answer. I just cannot understand it. And they do the same thing in AdMaths. A6, you're a joke, you know. CXC is that joke exam, you know, when you really think about it. You know, watch this now. Here's my log function. It's my log function here, so we can put in all of them things. So base 8 of 18. No, sorry. Of 18, right? Plus 3 times log again. Base 8. This time it is of 2. Then I am subtracting 2 times log again. Base 8 of 3. So the answer is what? 1.3, which is 4/3, you know. 1.3. That's the answer, you know. Calculator, give me that. If you can even show it as a fraction. Show it as a fraction. See there? But then give me 1.3, which is thing that I don't know why it don't show me the 4/3. We're going to give me 4/3. I don't know why it don't show me the 4/3, but this is 4/3. So 1.33333, which is 4/3. 1 1/3. Right? That's his answer, you know. That's what the calculator can be used to give me. And I'm sure you know, if the calculator can't do the function like this, right? I can just write that as, I'm sure work it again and show you now. The calculator can't do this. The calculator can't do this, but I'm just going to use log to base 10. Watch this now. So log of 18 to base 8, I'm going to put that as a fraction. I'm going to write it as a fraction. I'm going to put the log of 18 over the log of 8 by the change of base law. I'm going to put 3 times. I'm going to put a fraction again. Fraction again. No, I don't want that. Don't want that. I want 3 times. What's this? 3 times, right? 3 times. Fraction again, right? Log of 2 now. Log of 2 over log of 8. All right? I get the same answer, you know. Then minus 2 times fraction again. Log of 3. Log of 3 over log of 8. Log of 8. So you get the same answer. Same exact answer. So I don't understand how CXC set these questions that are totally numerical. Where somebody can just put it in them calculator and get it right. All depends on the type of calculator that you have. I just can't understand it. I just cannot understand how they do it. They do it in AdMaths as well. A lot of questions they can just put the values in the calculator and work them out. Understand me? When I come up on any more of them, I show you. But how do we work this out though? To show working. You have to use the laws of logs, right? So the answer is clearly this, and we can mark it from now. We're using the laws of logs to simplify this, right? I want to get rid of this in front of that and that in front of that. By the law of logs, them come up with as 4, right? That's what happens first. So those go up on the top, so we mark it. This come up here, so, and this come up here, so, right? Using the law of logs. So I'm gonna get log, it's going to become log to base 8 of 18 plus log to base 8 of 2 cubed, which is 8, and minus log to base 8 of 3 squared. And these 2 go up here, so I get 3 squared. So it's log to base 8 of 18 plus log to base 8 of this is 8 minus log to base 8 of this is 9. Ready now? It becomes 1 log to base 8 of what? 18 times 8 divided by 9. The radius, this process means multiply 18 times 8 divided by the 9. 9. So the 18 divided by the 9 is 2, and 2 times 8 is 16. So I'm gonna get log to base 8 of 16. All right, let me see what does that mean now. I want to simplify that. It's smaller. And if I want to get the 4/3, I need to get rid of the logs. Get rid of the logs. All right. So I'm gonna get We said 2 into this was 2 times. So we get log to base 8 of the 16, right? Log to base 8 of 16. Log to base 8 of 16. Is it 16? Yeah, 16. All right. All right. So I will log to base 8 of 16. How do I reduce and get the final answer? All right. So this is a multiple of this, but not a power. So maybe what I need to do is do a change of base. Change of base law and bring them to base 2. And this can be brought to base 2, this can be brought to base 2. Maybe that's what I need to do. Because this is not a power of 16, a multiple of 16. All right, so I can bring them to base 2. All right, so I'm going to write it therefore as log to base 2 of 16 over log to base 2 of 8. And the 16 is 2 to the 4th power, so it becomes log to base, write this up here, just to get the space. Put this up here, so just for the space, put this up here. That becomes that, shift this all over. So you see, it's a good thing we can use a calculator, because I mean maybe this is too much. But maybe if I approach another way, I finish quicker, you know. Just our see to approach it now. All right? It's just a matter of how I see to approach it right now. But then even once you reach to here, you just plug that in a calculator and get the answer still, right? You can use a calculator. So you have to work these down to the end. I'm just working it out. So you wouldn't do all of this on a multiple choice paper, right? But I'm just working it out. So this 16 is 2 to the 4th power. So then this continues as log to base 2 of 2 to the 4th power over, and this is 2 cubed. So you get log to base 2 of 2 cubed. The 2 powers go to the front, so you get 4 log to base 2 of 2 over 3 log to base 2 of 2. Clearly, this is 1 and this is 1. They cancel each other. So you end up with the 4 over 3. Maybe I do too much work somewhere along the way. I don't know. Maybe I do too much work. I don't know. Oh, you know, so this is 1 though. That 1, you know. Log to base 8 of 8 is 1. That is 1. But then in any case, that is it. All right, multiple ways to do it because it's logs. The trigs and logs usually have multiple ways to do them because of all the various rules and identities that can be used. So usually they have a lot of different ways to do them. This question right here, so now. This question tells us that this is equal to that, the more log to base 2 of A. This is the A now. So it means that some change of base took place. I watch this now. I'm going to start with this. I want to get this, you know. So I'm going to try to get log to base 2 of A first. Then I can use that change of base law. Watch this now. The reciprocal one. Watch this now. So this now is the same as, I want to get the 2. This is the same as 2 to the 4th power, right? So this expression, this side is going to become log to base A of 2 to the 4th power. And the equation is still, that expression is still equal to 5. The 4 comes to the front. So I get 4 times log to base A of 2 equals 5. So the log to base A of 2 is now equal to 5 over 4. Watch this now. So this log to base 2 of A, log of 2 to base A is the same as 1 over. I'm going to make this smaller now and shift it up. I'm going to shift this up a bit. I'm going to shift this up.
So you're just saying that is if A is equal to 1.
No. You have to know the laws of logs in the boss. At the back of your hand, you know. You have to know the laws of logs. I'm going to show you. So this now, this thing is the same as 1 over log of A to base 2, you know. That's a law of logs, you know. It's a change of base law, just the same, you know. I'm going to show you. And this is equal to 5 over 4. So that equals 5 over 4. Let me shift this over somewhere. But this is really small. That equals 5 over 4, right? You can write my answer. means that this equal to 4 over 5. The reciprocal of this equal to the reciprocal of that. So this means that log of a to the base 2 is equal to 4 over 5. 4 over 5. This is answer up there. All right, let me show you this law now. What the law come up. I'm going to show you so quick. Let me take a space right here. I'm going to show you. I can show you up inside. You know, let's put down a box. In red. Let me show you. You have to know the laws of logs. Change of base law. Watch this now. Log of a number to a base. You can have a new base. But suppose you make the new base be n. Right? Then it will be log of n to the new base n over log of b to the new base n. And this is 1. So then to become 1 over log of b to base n. That's how I go from that to that. So essentially, you can flip around these two and take the reciprocal. So bottom line, you know. But you go through the change of base. You just make the new base to the n. Both of them. And then this is 1. So I don't have to write this step. I can just jump from this straight to that. You have to know that rule. You have to know all the rules. I mean, that's what I just use right now. You have to know the rules, the laws of logs. All of them. You're doing pure maths. You can't see a law of log and it looks strange still. You have to know all of them. Right? You have to know all of them. Right? So I don't have to write this step. I just do that. Reciprocal. So the log, so you write using any other two values, m and n, or p and q, or a and b. The log of a to base b is equal to 1 over the log of b to base a now. You have to know that. You have to know them something at the back of your hand. The more things you have in your head, easy mathematics is, you know. So you have some laws where you just have to know. You have more things you know in your head, identities, rules, laws, formulas, formulae. Have everything in your brain. Mathematics get easy. Put them in your brain. All the laws them of logs, all the laws of indices. Right? And you learn the laws them back and forth, left to right, right to left. Learn all the trigger identities. Learn all of them. Put them in your head. Don't depend on a formula sheet for them. Sit down and put them all in your head. The questions them just get easy, just like that. I'm telling you. This question says, which of the following interval is the domain of this? Which of these is the domain? Which of them is the domain? Which of them is the domain? All right. So look what is happening here. Firstly, I want the function to be real, right? So the domain is always such that you want this to be able to work out. So because of the square root of x part up here, so the x has to be greater than or equal to 0. Okay, you can't put a negative number under there. And then on the denominator cannot be 0. The denominator cannot be 0. Right? So this is the first line based on because of the root of x. And then for the denominator, yes or no. This comes from that. Then for the denominator, no, it cannot be 0. So the x squared minus 9 cannot be 0. Cannot be 0. Because if it is 0, you'll be dividing by 0. What that means is that your x cannot be plus or minus 3. Cannot be plus or minus 3. Which of the following intervals is in the domain? Right? Which of them is in the domain? Which of the following intervals is in? Which of the following intervals is in the domain? All right, so x has to be greater than 0. I can't put it here, so it means that we can't accept this one because that will give me negative. All right, and see the next, and this also will give me negative. So I'm taking out what can be in the domain. Can't have no negative in there. Can't have the negative in there. See that? So the x greater than or equal to 0, yeah. Bang. Watch this now. I'm saying it also has to be less than 3. So that is in the domain. Greater than 3 in there too, you know. But let's say which one is in the domain. So this is okay. Greater than 3 in there. But this can in there and this can in there. But this part can be in there. And the less than 3 can be in there. I say we say it can't equal positive or negative 3. So therefore the answer is 2 only. Understand that? Understand that? So I can say for this one, I can just to make a note. Just to make a note, I can say also, I can say x greater than 3 is also in the domain. But they never ask for everything that is in the domain. Just ask which of these 3 is in the domain. X greater than 3 can also be in the domain. They just can't equal 3 and can't equal negative 3. And also we are saying it has to be greater than 0. So the answer must be this one. 2 alone. 2 only. So remember, tick it. So since I put x on those 2, I'm going to tick this one. So it's 2 only. 2 only can be in the domain. Like these questions. I said that one before and then the paper. That is it. Remove these so that they don't hide the information. So the negative 3 can be there and the negative 2 can be there. So that those negative values basically. So you see, because it's greater than negative 3, it means that we also start at negative 2, which you can't have, right? In this interval, you can't have it. And this stuff, because it's greater than negative 2, it also means that this interval would have negative 1 in it. And you can't have it. That's why I'm xing those out. You get me? That's why I'm xing those out. Not because of the negative 3, because it says greater than negative 3. So it's not including negative 3, but the interval is including a value like negative 2. All right, so that's why I'm xing them out. Next one. All right. The solution set for this is what? All right, so I see 2 modulus over here. So, all right, equals 6. All right. Okay, use the process of elimination for this, but the answers are on the paper. You can use the process of elimination. So for this first answer, I say x equals negative 3 and x equals 3. Both of them will work, you know. Because when I plug negative 3 here, so, and here, so, this one becomes negative 6, but the modulus of negative 6 is 6, and this one becomes 0. So that will work. And if I plug in the 3, the same thing will happen. If I plug in the 3 here, it should become 0, but here it becomes 6. That value will work. But what about values in between them? This is referring to values in between them. You know? So I know that the 2 of them will work. This and this will work. So since both of them will work, I know so this is not the right answer. You know? Right? Because this is saying I have to go between 0 and 3. And I did say negative 3 will work. So it means that I can eliminate this one. I can also eliminate this one, you know, because I just showed that the negative 3 will work and the 3 will work. And this interval don't include the 3, so I can X out this one as well. So this one now, I'll have to try values in between. So a value in between negative 3 and 3 that you can try is actually x equals 0. So we try x equals 0 as a simple value. Put 0 here, so this will become negative 3 the modulus, plus this will become 3 the modulus. So the modulus equals 6, but the modulus of negative 3 is 3. So it means that any value in between negative 3 and 3 can also work. So this is the answer. So even though this can work, you know, it does not include values in between negative 3 and 3. So I would have to put this as my answer. Understand that, Brandon?
Yes, sir. Modulus is actually one of the one things I'm pretty okay.
You good at modulus. All right. So can you, suppose you want to use a graphical method, could you, let me show you, try to can show you something now.
Could you repeat that?
No, I want to show you something. Could you sketch a graph of this and put it equals 6 and see where it equals 6? To use a method like that. Could you sketch a graph of this?
If I could.
Sketch a graph of this side, like y equals this side. And then you see where it equals 6 as a method of solving this. Would you sketch it?
I believe so.
What would be your approach to sketching?
All right, so I remember what you did earlier. You were saying that I would draw the y equal x graph, but then I would cut it in half, right?
Huh? How do what?
You would cut it in half and cut out the negative point?
No, man, I modulus this, man. Modulus just have to do with, you can't, no part of the graph can go below the x-axis, you know. That's all that means, you know, modulus, you know. That now have to do with the quadratic where we are cut in half because it was many to one, like that, and cut in half. Total different something like that. Let me show you where it's sketch a graph, right? So if I want to sketch, let me just show you, just since we're here, right? Let me just show you how you would sketch a graph like that. Put it, you can fit it in this in a little box right here for you. Show you. I'm going to zoom it up and do it here. Right in this little box. Right here. All right. So if I want to sketch y equals the modulus of x minus 3 plus the modulus of x plus 3. Because there are two parts of the modulus. There are two critical values. The critical value on this one is 3. The critical value is what will make it equal 0. Now. That's what the critical value is. That's where the modulus function sort of make a change. And this one will be negative 3 because it becomes equal 0 when the x is negative 3. So those are the two critical values. Clearly negative 3 is less. So that's what I'm going to do now. Since this critical value comes before this one, I'm going to flip them around and show you something. So I'm going to write as y equals the modulus of x plus 3 plus the modulus of x minus 3 instead. So I'm sketching the graph. The two critical value on the graph is going to be where x equals minus 3 and where x equals 3. Now what happened now is that these two functions, they change depending on which side of the tree and the negative tree you're on. So you have three sections and you have the negative tree and the tree has two critical points, right? You have values to the left of negative tree. You have values in between the tree and the negative tree, and then you have values to the right of the negative tree. That's what it works now. So it's like the graph, each of the modulus functions change depending on which side of the tree and the negative tree you're at. Watch it now. Watch this now. The first thing you have to remember about modulus, one thing you have to remember about a modulus is that a modulus is really two functions in one, you know. That's what a modulus is. Modulus function is really two functions in one. Because it is positive when itself is positive, but it is negative when itself is negative. So for example, you see the modulus of x minus 3, the critical value is 3, right? Critical value is 3. The critical value is 3, you know. So this is equal to x minus 3 when the x is greater than or equal to 3. But it's equal to minus, it's equal to the negative of itself. So it's equal to the negative of itself, right? The negative of what is in here. So it's equal minus x plus 3. That's what it becomes, you know, minus. I can put the minus outside, become minus x minus 3 when the x is less than 3. So the modulus function is of this or this depending on which side of the tree you're on. The same thing happened to the other one, the x plus 3. So the x plus 3 now, the modulus of x plus 3 is also two values in there, but the critical value now is negative 3. So when you're on the right of the negative 3, it remains as it is. And when you're on the left of the negative 3, it becomes the negative of what it is. So it remains what it is, which is x plus 3, when the x is greater than or equal to 3. It means what it is, because it's going to stay positive, don't it? But when the x is less than 3, like for example, negative 4, right? You're going to get a negative 4 plus 1 in there, plus 3 in there, you're going to get a negative 1. So in order for the negative one to become positive, you're going to have to negative it. You're going to have to negate it for it to become negative, for it to become positive one. So the function instead becomes minus x plus 3 when the x is less than 3. That's what it is now. So what does that mean now? Look what is that? Look how we want to put that together now. So this negative 3 is the critical value for that. That's why I put it. That's why I switched them around. You know, I want to put the function over its modulus value, and this over critical value, and put this function over its critical value, because I know now that to the right of this tree, this function stay as it is, but to the left of this tree, this function becomes the negative of itself. Anywhere to the left of this tree, this function becomes the negative of itself. We're talking about this one now. To the left of this negative tree, this function becomes the negative of itself. But anywhere to the right of this negative tree, it remains itself. So look what we're gonna do now. The function has 3 sections, you know, 3 sections. Watch it now. You see over this side, over to the left of negative 3, this negative and this negative, because both of them are to the left of the negative 3. So the two of them negative. So the sum of them become the negative of this and the negative of that. Two of them, you add in the negative of both of them. So the two of them going to add to, watch this now, they're going to add to negative x plus 3 and negative x minus 3. Over to the left side of negative 3. And left side of negative 3 on the graph, this is what they become. What that work out to? That work out to negative 2x, so they become negative 2x on the graph. So on the left of negative 3, the graph is negative 2x. What happens in between them now? In between them, this one is to the right of it, so it becomes itself, it remains itself. So this one remains itself, so it remains x plus 3. But in between them, this one is on the left side of it, so it becomes the negative of itself, so it becomes minus x minus 3. What is add up to now? These add up to, if you add them up, you add up this, you're gonna get 6. Because this positive wipe out that negative x, this and this become 6. So you see it becomes 6 in between them, 6. So what the answer was 6, right? So see, between them. You see that? Between negative 3 and 3. So it work out itself. See that?
Yes, sir.
Good. And then now, to the right of the tree, both of them remain themselves. Both of them remain as they are. So this stays as x plus 3 on the right of 3, and this stays as x minus 3 on the right of 3, and they add to 2x. So if I'm sketching this graph now, if I'm sketching this graph, watch it now. I'm gonna sketch this graph now, right? Based on this information, I'm gonna sketch it right here. So this will be my y-axis. This will be my x-axis down here, so right? Let's put it down. Everything above the x-axis, so I don't have to think there. So I have negative 3 over here, so and positive 3 over here, so right? You see, in between negative 3 and positive 3, the graph is just y equals 6. So see 6 here, so let's say this is 6. The graph is just y equals 6, right? So straight across. So the graph in between this, in between the negative 3 and the 3, it's just 6. Y equals 6. This pass through 6, right? So on the y-axis. Then to the right of the tree, from here, so now to the right, it becomes 2x. 2x is a graph going up, so 2x. This is 2x. And to the left of this thing, to the left of the negative 3, so negative 3 there, it becomes negative 2x. And negative 2x go like so. This part of the graph is negative 2x. And that's how you could sketch that graph. See that? Understand that? So that's how that graph will do, this function.
Yes, sir.
This function. That's how it will look. And so if you're looking for where the x equals 6, then it's right inside of some. You see that? The function equals 6 right between the negative 3 and 3. So that would be a graphical way to do it. But we never need it because why? Why we never need it? Tell me why we never need to do the graph. Tell me. Tell me why we never need to do the graph to solve it, to do it, to get the answer over this. Why?
Because they already gave us the answers.
Why solving this equation? This is a graphical way to do it. Why is it that we did not need to do it this graphical way in this question that they gave us on the multiple choice paper? Why is it that we did not need to do it and work it out? Why?
So because we could just input the values?
Because the answers are right in front of you. You can just use the process of elimination and work it out. Remember, the answers are on the paper. So when a question is going to take a long process to do, but they try the answers. It's quicker. Try the answers. You understand me?
Yes.
So just try the answers in there. Try the answers in there. And I tell you that this is the answer. Try the answers. This tell me that the negative 3 and the 3 will work. So because the negative 3 and the 3 will work, automatically this is not right and this is not right. Because this excludes the negative 3 and this excludes the positive 3. So them two are automatically not right. And then this one now is just a matter of determining if a value in between the negative 3 and the 3 will work. So I'm going to try 0 and the 0 work. Done. See that? I never go through all of this. Because the answers are there for me to try and get the right answer. Don't forget the answers on the paper. Always remember that. The problem with multiple choice, is that people do multiple choice questions as if it's a paper 2 question they do. When the answer is right there, you just need to use the process of elimination a lot of the times. I look at the answers and see which one makes sense. Try the answers in the question if necessary. The answers are there. A question like this, I will try to work it out. You can actually solve this too, There's a method of and solve that, Span it out and do a whole for work, Right? But why do that? Right? Why do that? But now you know if you sketch the graph of those. So you get the critical values, find where the critical values are, and then you go to either side, all sides of the critical values. Right? And put the function them on over the critical value. To the right of the critical values, they stay as they are. To the left of the critical value, they become the negative of what they are. Just remember that. And you're good to go. All right? Just remember that. Anyway, let's continue. That is when the x value is positive still, At the x value negative, going to be the other way around. All right? That's when the x value is positive. All right? It's going to be the other way around if the x value is negative. But anyway, let's continue. All right. So right here, so now, boom, bang, boom. All right, let's not forget I'm doing a multiple choice paper. So this question says f is equal to this, where k is, let this come down. Oh, k is greater than, x is greater than k, x is greater than k, I don't know why they tell us that. And k is a real number. I must find f to the minus 1. So I want the inverse of this, the inverse. So I'm going to start. Just use it. I'm going to start by saying f equals, I'm going to inverse. We don't have time for that. Multiple choice now. I'm going to write the inverse. So the inverse is going to become, you see, this x is going to become f to the minus 1. This x right here is going to become f to the minus 1. Eh? So I'm going to get, when I form the inverse, I'm going to get x equals e to the 2 times f to the minus 1 plus k. This is my inverse function, inverse. All right? That's my inverse. I'm trying to make this a subject. Ready now. Here over the k first. We get x minus k equals e to the 2 times f, e to the 2 times f to the minus 1. Shift this down. Some space. All right. Then I want to get this from out of the power, so I take logs, but because this is e, I have to take ln. So I'm going to shift it over and show that I'm taking ln of both sides. Let's shift it over. All right, so I'm going to take ln of both sides in red. log the base E. I'm going to take ln of this side and take ln of this side. Take out the bracket. Leave the bracket out on this one. Leave the bracket on this one. Then this now comes to the front of the power. All right. So I end up getting I see the answer already. I'm just working it out. X minus k equals 2 times f to the minus 1 ln e. So the ln e is equal to 1. This ln e is equal to 1. Log the base e of e is equal to 1. So we really only have this left on the right side. So I'm going to divide by the 2. So I'm going to get f to the minus 1 equals ln x minus ln of x minus k all over 2. And that answer is right here. Same thing. X minus k. Yep. Yep. That is it. Don't put this one in. Don't put that one. Easy stuff. Easy. This question now. This question says, given that alpha, 2 alpha, and 3 alpha are roots of this equation, what is the value of a constant k? All right. So the only value we know in this equation is that. We don't know the k. The constant out here shows the d, you know. If you were to write out the a, the b, and the c, and the d from this, the a would be equal to 1 coefficients. The b would be equal to k, that's coefficient of x. There's no x term in it, so the c will be equal to 0, and then the d will be equal to 48. Now this d relates to the product of the 3 roots, and these are the 3 roots. You know, the product of the 3 roots. So the product of the 3 roots equal minus d over a. So we can say that, you know, the product of the 3 roots, which is p3. Product of the 3 roots, I call it p3. Product of the 3 roots is minus d over a. So the product of these 3 roots, if I multiply them, it's going to be alpha times 2 alpha times 3 alpha. That's the product of the 3 elements. It equals minus 48 over 1. All right. So this right here so now is really 6 alpha cubed. 6 alpha cubed equal minus 48. I'm doing too much work and I don't need to do so much work. Let me shift it over. I'm doing too much work. You can see that my alpha is 2 already, you know. Doing too much work on this question. Too much work, Mr. Shaw. No problem. Somebody gonna read it and see the solution. So it can be worked out. So from this, you're gonna get alpha equal negative 2. You're gonna divide by the 6, and you're gonna get the cube root of negative 8. So alpha equals the cube root. Let's write it. Alpha equals the cube root of negative 8, which is negative 2. So if that is the case, it's not this small. The space to write is so small, guys. So small. All right, so let me continue and write it beside it. I'll shift it up and continue under it. So if alpha is minus 2, then we have the roots. The roots are, remember now, is alpha, 2 alpha, and 3 alpha. Those are the 3 roots. So the roots will be minus 2, minus 4, and minus 6. Those will be the 3 roots. And that's what k is. K relates to the sum of the roots. Sum of the roots. So the sum of the roots, remember now, the sum of the roots equals minus b over a. Minus b over a. So the sum of the roots is this, you know, sum of them. That's what, negative 12. So that sum of the roots is negative 12. So negative 12 is the sum of the roots. Equal minus k over 1. So therefore, k equals 12. So then it says k equals 12. I do too much work for this question. So this was a formula that we used right here. And this also the formula for the sum. Question erroneous doing. Something wrong with that question. Because if you notice, them put in C equals 0, which relates to the product of the roots. Pairwise, when you pair them, that's saying that it will be 0. That's what this is saying on the C, because there's no C value there. There's no X value, but that is not true. Because if you multiply these in pairs, you're going to get a positive value. If you multiply them 2, they're positive. Multiply them 2 here, it's positive. And multiply them 2 here, it's positive. So the pairwise product must exist. So the question is erroneous. By telling us that the C equals 0, yeah, the question is right. So they left out something. This equation is not true, but it's not needed for the question. But if you look further into it, this is not true. This is not correct. This is not correct. This is not true. But sorry, go on. They make up a question and they put in values that you need to solve it. Right? That's all. It was relevant, but this is not true. That the C equals 0. This next one down here says the values of x between 0 and pi. That means I want to work in the first 2 quadrants, that satisfies this equation. It's a quadratic in cos, It's a quadratic in cos. So we're going to factorize it. Factorize it. We're going to put the blue again. Like we're solving it, right? We're going to factorize it and put it equals 0. So the factors of the 2 classes, 2 cos theta, Since I want middle term is 3, I need to put this 2, the 2 over here to make 4, and the 1 there. So the signs in the bracket are different. Give the greater product the plus, the greater product is the far product, which is 4, but that positive is negative. So I'm getting cos theta equals half, and I'm getting cos theta equals negative 2. But this one is not valid because cos of an angle cannot be outside negative 1 or negative 2. Negative 1 or positive 1, so this is not valid. So we're really only solving this one, which means that the angle is 60 degrees because the cos of 60 degrees are half. You're just supposed to know those things. And 60 degrees is pi by 3. So the answer is pi by 3, So theta is pi by 3, which is cos to the minus 1 of a half. Theta is pi by 3. In the exam, when I write out all this, there's no the answer pi by 3. 60 degrees. Cos of 60 degrees a half. Which is right here. Pi by 3, 60 degrees. Just know those things like how you know your name. Like pi by 3 is 60 degrees. Pi by 6 is 30 degrees, and so on. This is a vectors question. It's an IJK question. So don't make this tricky and think it's an I and J only, right? So they give us this as A. They give us this as B. Remember, write them as column vectors. It's just always easier. We have the column vector. So I'm going to write the A. Let's put it right here. So the A, I'm just going to write it beside it. The A is 1 minus 1, 0. I don't know, put a K. And the B is, let's put it beside it. B is minus 1, 2, 3. Minus 1, 2, 3. All right. So OP is this combination of them, and OQ is this, also a combination of them. And I want us to find scalar of OP to OQ. So we need to find them. We need to find OP and OQ. So let's go. So the OP equals.
Wait, sir, did you do number 17 already?
17? 17 there. I'm gonna see. Hey. All right, thanks. Let's see. All right, 17 says angle between these 2 vectors is, all right, first thing I'm going to do is see for 90 degrees by doing the scalar product. Right? Let's see for pi by 2 by doing the scalar product. So I work it out. I'm going to do the scalar product first. A dot B equals 2 times 1 equals 2 times 1 minus 1 times 4 plus minus 1 times 4 plus 2 times 1. 2 times 1 is equal to 0 now, because it is 2 minus 4 plus 2, which is equal to 0. Therefore, the angle is 90 degrees. Pi by 2, they are perpendicular. A is perpendicular to B. Let's write it like this. So therefore, the scalar approach is 0. You can say therefore A is perpendicular to B. This is symbol for perpendicular. All right, back to this one now. So as I said, we need to find the OP and the OQ down here, right? So boom bang. The OP is A plus 2B. So we're adding 1 of this plus 2 of that. So we correct it out. So it is 1 minus 1, 0 plus 2 of this. 2 times that is negative 2, 4, 6. And that works out to be 1 minus 2, negative 1, minus 1 and 4 give me 3. And then 0 and 6 give me 6. That is OP. And I need OQ now. OQ. And OQ is 2 times the first one minus the second one. So 2 times the first one becomes 2 minus 2, 0. And then we're subtracting the second one, which is minus 1, 2, 3. That works out. This minus is a plus. So I get 2 and 1 is 3. Minus 2 and minus 2 is negative 4. And 0 times 3 is 0. And then we're doing a scalar product between this and this. So OP dot OQ equals negative 1 times 3 first. Negative 3. 3 times negative 12. Negative 4 is negative 12. And then something wrong. I'm not going to answer this one. Something is wrong. Something is wrong. Did something wrong. Oh, it's a negative 3. This right is a negative 3. 0 here, so see, negative 3 right here, so that's a mistake. Minus 3 is that one. Okay, so it becomes 6 times negative 3, negative 18. And so this time this is negative 3. This time this is negative 12. This time this is negative 18. Negative 18. So these two become negative 30 and 3 more is negative 33. This is negative 33. Put on the side right here. That's 18. 19 now. 19 says curve is given by those two parametric equations. Cartesian equation is which one of these? All right, so basically I want to get rid of the t out of those two equations. This is the one with the t that can be the subject. But the answer is on the paper. I'm going to say that number 9y. So because I'm over 9y, I'm going to create my 9y from now. The answers on the paper, you have to use it. So from this, I'm going to multiply by 9 to create my 9y. Then all I need to do now is substitute into the right side. Multiply by 9. Just because the answer is there and I can see that they express it by 9. So multiply by 9. The answer is on the paper. Use it to help you. Don't work blind. So 9y equals 9t squared plus 9t minus 9. 9 times 4 is 50. 9 times 6 is 54. Yeah, 54. 54. That's a 54. That's right. 56. 54. And then now from this equation, I can make t the subject. Or 3t. You can make 3t the subject. 3t. Why? I can get 3t into this and 3t into this. So, so the fraction get eliminated. So I'm going to write from this now. We'll just put it right here. So I'm going to write 3t becomes x minus 2. 3t is x minus 2. All right? And I'm going to substitute this into this now. Sub into that. So I'm sub into this so now. I'll get my 9y equals. You see this? That's a 3t squared, you know. 3t r squared. This is 3t r squared. So it becomes x minus 2 r squared. X minus 2 r squared. You see this now is a 3 times 3t, you know. Because that's a 9t. So I'm going to put plus 3 times x minus 2. That's 3 times 3t. And then subtract by the 51. 54. Just work down and see which one it is now. So it's equal to, that's a perfect square. You're going to expand it out and get x squared minus 4x plus 4. If we expand this, I'm going to get 3x. I can put them under here, so I'm going to get plus 3x minus 6. And then we get back the minus 54 there. Minus 54. Add up everything. I'm going to get x squared. This becomes minus x. Minus x. And then all this becomes what? This and this is negative 2. Negative 2 and negative 54 become negative 56. That's what 9y equals. 9y. Add it up. So the answer is this one. The first one. Yep. First one. Right there. Just have to be smart. Just, the answers are there. So you see that them expressing in terms of 9y. Let's get the 9y from the beginning, from the get-go. And so your focus is now solely on the right side. Get your 9y already. And then see which one of them work out. Which one of them the right side work out to be done. Got to be smart. The answers are there on the paper. Use them when you can. This one says, the variable point P moves so that it is the same distance from these 2 points. The equation of a locus is what? So it's quite simple. So basically then, it's like you have the point xy, the point P, and the distance to this point is the same distance to that point. That's what the basically is saying. Right? So what will be the distance between these 2 points? Between this point and this point. The square root business, it becomes the square root. So it becomes the square root. Let's call this distance, that's our reference, right? Let's call this different. Let's call this distance, D1. Let me equal and call that one a D2. And we have said D1 equal D2. Two distances are the same. Now what is D1? D1 using the square root business, which comes from Pythagoras theorem, is the square root. Difference in the x value squared, x minus 1 squared. X minus 1 squared. Looking at the answers as I work, X minus 1 squared, plus y minus 6 squared. I don't want to answer this. The answer, we'll do anymore. Done. And you go on the next side now. This is the D1, So let me shift this over. This is D1. D1 equals, and I put D2 here so now. That's the distance between these 2 points now. And the same approach becomes equal to the square root of x minus 3 squared. X minus 3 squared plus y minus 2 squared. Y minus 2 squared. So that's why this is the answer right there. Yep. Good to go. Soft with a capital T. All right, let's go. Next one. This one says the set of values of K for which a straight line intersect this curve at 2 distinct points. In other words, when you put the line and the curve together, like you're solving them simultaneously, you're going to get a quadratic equation. That quadratic equation must have 2 different roots. And so the discriminant for that quadratic equation has to be greater than 0. All right, so let's set it up. First, you're going to act as if you're finding a point of intersection, right? Where they intersect. So it's going to be that this equals this, where they intersect. So it's going to be that x squared minus 2x equals kx minus 4. And the 2 y values become equal where they intersect, where they meet, right? You're going to set it out like a quadratic. Care about these. So we're going to get careful now. X squared. Let me zoom it up as zoom up the work. Right? I'm working with those now. So I'm going to get x squared. Carry this over. May I get what may I get? May I get minus. May I get minus. I get minus 2 plus k times x. Because it's going to become a minus kx now. So it's minus 2 and minus k times the x. And then 4 come out, come a positive 4 equals 0. What them say now, because they intersect at 2 points, the line and the curve. This equation that is searching for where they intersect, it has 2 roots. This equation has 2 distinct roots because the line and the curve intersect at 2 distinct points. So this has 2 distinct, 2 different roots. And if it has 2 distinct roots, then the b squared minus 4ac for it, which is what is under square root sign in the quadratic formula, has to be a positive value. That's why we get 2 different values from that formula. And the b squared is this. I don't have to put on the negative enough because the negative squared and the positive squared is the same. So I'm just going to write 2 plus k squared, that's the b squared, minus 4 times the a. The a is 1 over here, so and the c is 4. That is now greater than 0. And so we're now solving this equation, this inequality, I mean. So we're solving. So we're solving now that inequality. And so the question is now, which one of these is the answer? I don't want to write this all the way down, All right, let's look at it this way. So it becomes 2 plus k squared minus 16 greater than 0. So how would the sketch for this be? If I were to sketch a quadratic for this, it be a smile. Look at this. If I expand it, I'm going to get a smile, right? I'm going to get a smile. Clearly, based on these answers, the values are 2 and 6. 2 and 6. Or negative 2 and 6. Or the more negative 6. So we'll see which one it is. We have to see which one it is. So I would sketch it first. And to see which one it is, let me solve this for the thing, you know. For the thing. So let's find the critical values. So go here and here. Critical values. This is my k-axis. My k-axis. I could treat this as my variable, you know. I can call it my x squared and treat that my variable, you know. And put that equal 4 and positive 4, you know. But my critical value is going to be where this equals 0. So it is where the 2 plus k becomes equal to plus or minus 4. If I just solve it equals 0, I'll get my critical values to go here and here. And it will be the k would be minus 2 plus or minus 4, which means that the k would be 2 and negative 6. 2 and negative 6. So this is 2, this is negative 6. And then now the inequality is above the x-axis. That means that I want up here, and up here, which are to the right of 2 and to the left of negative 6. To the right of 2 and to the left of negative 6. So I want the right of 2 and the left of negative 6. To the left of negative 6 and the right of 2. So my answer is C. This could be a paper 2 question, the next question. Could be a paper 2. But that is it. Just trying to do some explanation stuff. So anybody get the paper and, or the video and or the paper and looking at it, then you know they can see the solution. Next one. What is this? Which one of these is the correct form for this? I'm gonna show you something now. Well, a lot of teachers when they're teaching this, right? Them do a long procedure. Them work out R and them square book, them square and add the terms and I don't need to do none of that when you know your identities. You don't need to know none of that. I'm telling you, I'm write it out down here. I'm gonna write it out for you. 4 different forms and what the result should be. For all 4 forms. Right? Which is basically the R sign, R cos I'm talking about, you know. R sign, R cos. 4 possibilities. Just 4. So if I have A sine theta plus B cos theta, the sign comes first. In that case, I'm gonna have R sine. Because the sign come first, I'm gonna go R sine. Because inside there is a plus, and when I expand the compound angle for the sine function, whatever sign is in the bracket, the same sign is out here. So I'm gonna put into theta plus alpha. Simple as that, you know. This is the format of it. And when is A sine theta minus B cos theta, since the sine come first, it's going to be R sine. And since you have a minus here, you must have a minus in here. Theta minus alpha. Then you have the case when the cos come first. In this case, now you have A cos theta, the cos come first, plus B sine theta equals cos come first, so it's going to be R cos. So here we are going now. When you expand a cos compound angle, if you have a plus inside here, you're going to get a minus out here. And if you have a minus in here, you're going to get a plus out here. So since you have a plus out here, I need a minus in here. So it's going to be theta minus alpha. Now when there's A cos theta minus B sine theta, this becomes cos come first. So this is R cos. R cos. This is a minus. I need to put a plus in here. Theta plus alpha. What is R? R is always the square root of A squared plus B squared, where A is the first value, B is the second value. And the alpha is always tan to the minus 1 of B over A. Tan to the minus 1 of B over A. And the B is the second value and the A is the first value. Those are all the forms, and you can understand them. You don't need to do that long working out, square both sides, add and all these things. And write them and divide to get the tan and sine of a cos is tan and all. You don't need that. This is what the R will always be. This is what the alpha is always be. Once you recognize that this one must be written like this one must be written like this, and you can understand why. This one must be written like that, and this one must be written like that. That is R. Voila, that's a must know. Easy. So back up to that now. Back up to here now. So I'm looking at this. My cos come first. So since my cos come first, right? And this is a plus. I know it's gonna be R cos. It's gonna be R cos. It's gonna be, let me zoom it up. Right here. So it's gonna be over for the blue. It's gonna be R cos. It's gonna be R cos theta. Since this is a plus, I have to put a minus in here when it's cos. Minus cos alpha. What is the A and what is the B? The A is 1. The number in front of the first variable there is 1. First cos theta is 1. And the B is 3. So the R then is the square root of 1 squared plus 3 squared. So the R is equal to the square root of 10. This is 10 and a yes in square root of 10. What is the alpha? The alpha is tan to the minus 1 of the B over the A, which is 3 over 1, which is tan to the minus 1 of 3. Tan to the minus 1 of B over A, 3 over 1, which is just tan to the minus 1 of 3. So basically, this value coming here, and this value is coming right here, so for the alpha. So which one of them that is? Which one of them that is? The arctan 3 is it another? The arctan 3 is the tan to the minus 1 of alpha. That's what I write it, arctan 3. So the root 10 there for the R, and then see the minus here we're supposed to have 5. So that size A, arctan 3. That size A. Simple as that. That's it. The more things you force in your brain, the better. Right? Arctan means tan to the minus 1. Arctan. You have to know says B over A. So these answers wrong as the one up. That is A over B. Tan to the minus 1 of B over A. So that's it. Next question up here. So let's do this proof. The proof is really. When you're doing proof, generally speaking, you don't work with tan and sin and cos at the same time. First, I'm going to just get rid of that tan. We will not work with sin, cos, and tan at the same time. So therefore, the first thing I'm going to do is write this as sin theta plus, I'm going to write this tan theta as sin theta over cos theta and put all of that over 1 plus cos theta. I know that this is part of cos squared and sin squared and this. One, if I get a 1 minus cos beside it, it becomes difference of 2 squares, which is 1 minus cos squared, which is sin squared. You have to know those things. So look at how to use it. I'm going to simplify this, but I'll get rid of that cos theta on the top there. So I'm going to multiply numerator and denominator by cos theta. After this, I'm going to multiply numerator by cos theta and also multiply the denominator by cos theta. I'm keeping an eye on these answers down here as I go, right? Working towards and let's see what will happen. So I'm going to multiply this time this. So I'm going to get sin theta, cos theta. And then this time this cancel the cos. I'm going to get sin theta over. I'm going to have 1 plus cos theta. When I multiply them in, no, keep them separate. 1 plus cos theta times cos theta. And then I realized that on the numerator I can factorize a sin theta. So I'm going to factorize out the sin theta. In the bracket, I'm going to get 1 plus cos theta. 1 from this, and cos theta from that, plus cos theta. Why did I do it that way? I have 1 plus cos theta and I here. So this cos theta on the denominator, I'm going to put it in front of this and put cos theta. And then I put back the 1 plus cos theta. And this is equal to tan theta, you know, because what happened now is that these two cancel each other. And the sine over the cos is tan theta. Sine over cos is tan theta. The answer is tan theta. Nice and easy like that. Bang. So you see, come back to the tan theta that we have there now. So that's not the only way to do it. I'm sure we could use other identities like change these instead. Right? I write them in terms of tan. But see, we went away from the tan and came right back to us. So that's okay. No problem. Next one. Number 24 says the curve whose Cartesian equation is this. So equal one, so one of them to be sin squared and one to be cos squared. Simple like that. Let's look at the answers now. This is the same as 4 squared under here, and it's the same as 3 squared under here. So, all right. So think of as if we're gonna put this inside the bracket equals sine, and this inside the bracket equals cos. All right. So boom bang boom bang boom bang boom. So this equation would basically become the same as x minus 3 over 4 squared plus y plus 4 over 3 squared equals 1. The parameter is t, so it's sin t and cos t. So this is the same. If we're going to make this equal sin t, so we can say, let's go for the purple. We can say sin t squared plus cos t squared is equal to 1. So we say this inside there, so it's sin t. This inside there, so we're going to make it cos t. And to be true. So we're going to say this and that, the x minus 3 over 4 equals the sin t. And if you notice, they're making the x and the y as the subject. So we make x the subject of this. We'll multiply the 4 and then carry the 3 and add it. So the x should be equal to 3 plus 4 sin t. 3 plus 4 sin t. 3 plus 4 sine of t. And then now, this now equals cos t, or cos t equals that. So we're gonna have again y plus 4 over 3. I can look for this one now. That one is there, that will go 3 plus, see here, 3 plus sine t, x equals 3 plus sine t. That is the answer. I don't go any further. This is my answer right here. So I have to work out another one. But I see that there. But I'm gonna work it out still just to make sure that it will switch around. It will switch around the things, right? So I'm gonna work out the other one still. So this now will be equal to cos t. This one. Plus this and this will be equal. So I'm gonna make y the subject of this one now. So I'm gonna multiply up the 3. So I'm gonna get y equals, it's gonna be 3 times that and then minus the 4. So it's gonna be minus 4 plus 3 cos of t. So you see, same thing. That is the answer right there. Good. All right, is it easy? This could combine with tan squared using the identity tan squared and sec using the identity of 1 plus tan squared theta equals sec squared theta, or it could be cot and cosec. 1 plus cot squared theta equals cosec squared theta. So you could get parametric equations again, you connect those as well, using those, right, to eliminate the parameter or write them as parametric equations. You could use those as well. All right, those are spin-offs from the sine squared plus cos squared equals 1. Those are spin-offs. You divide one of them by the cos and divide the other one by the sine. You get those. All right, next one. Express as a product of two trig ratios. What is this equal to? Say that's the sum of two sines. That's what this is. Sum of two sines. The sum of two sines is sine cos. What do I mean by cos? Sine cos. It is twice the sine of half the sum times the cos of half the difference. I call it sine cos. Because the factor formula, which basically is about the sum and differences of the sine function and the cos function, and the sum of two sines is twice the sine of half the sum. The sum of the value here and here, and the cos of half the difference. This and this. Now I like, since it's a plus, I like when the 3 theta one is in front. So the first thing I'm going to do is write it as sine 3 theta plus sine theta. Put the 3 theta one in front. So I don't have no negative to deal with when I do it that way. Because the difference will be 3 theta minus theta. Is always the first minus the second. The first minus the second. So it becomes equal to, you have to know it, the factor formula. Write out all of them for you on this page. You know. Twice the sine of half the sum times the cos of half the difference. Sine cos. The sum of two sines is sine cos. Twice the sine of half the sum. That is 3 theta plus theta over 2 times the cos of half the difference. 3 theta minus theta over 2. So this will become 2 times the sine of, this becomes theta, right? Because it's, 4 theta over 2 is 2 theta. 2 theta, and this becomes theta. 3 theta minus theta is 2 theta over 2 is theta. That's the answer, you know. The first one, no. Yeah, the first one is the answer. Right here. First one. Now, those things are on the formula sheet, you know, or in the formula booklet. You know. Let me see if it's on the formula sheet on this. If we have the formula sheet here, so let me see. No, I don't have it. It's not here. It wasn't added to this. But it will be on the formula sheet. But them things, they can know them in the head. The more things you know in the head, the easier these things are, as I keep saying. I write them out down here for you. Factor formula then. Write them out down here. So. Right? Write them out on this paper. First, you have the sum of two sines. Sum of two sines, like sine of A plus the sine of B. That is equal to sine cos. Sine cos. And if you know the compound angle, they are derived from the compound angle, right? So sine cos. What do I mean by sine cos? I mean by I put sine first, cos second, and it's twice in front of it. So it's twice the sine of half the sum, a plus b over 2 times the cos of half the difference, a minus b over 2. That's the sum of two sines. You have the difference of two sines. The difference of two sines now is cos sine. Switch them around. The difference of two sines is cos sine. So sine of A minus the sine of B. That is cos sine. Cos sine. Cos sine. Meaning twice the cos now of half the sum times the sine of half the difference. That's when you have the difference of two sines. That's what they get. They get cos sine instead. Then the sum of two cos now is cos. Yes. The sum of two cos is cos. So like the cos of A plus the cos of B is cos. Cos. Just like when you expand the compound angles, it's cos. Right? As is cos A cos B minus sine A sine B is cos. So the sum of two cos is cos. So it becomes twice the cos of half the sum times the cos of half the difference. Cos. We have the difference of two cos now. That's the only one that have a minus in it now. So the difference of two cos, like cos A minus cos B is sine. So it becomes minus sine. That's the only one that has a minus on it. So it becomes minus sine, which is twice the sine of half the sum times the sine of half the difference. So it's always half the sum, half the difference. Half the sum, half the difference. Half the sum, half the difference. And it's always twice. The only one that is minus twice is when you have the difference of two cos. Can't forget those things. Put those things in the head, and with mathematics, with trigonometry, get easy. Learn all the trig identities. Learn all of them. They can hold in your brain. You want to get tricks. You want tricks to become easy for you. Learn to put all the trig identities in the head. Don't depend on a formula sheet for them. So that's what just did up here. So this was a sum of two cos. It's always better when the larger vowel is in front, right? The larger angle is in front. So that's why I switched that around. So you don't have the negatives to deal with. But one thing you must know about the negatives, right, is this. In case you get a negative, you must know that the cos of a negative angle is still equal to the cos of the angle. But the sine of a negative angle is minus sine of the angle. Same like tan. Tan of a negative angle is minus tan of the angle. So this is good to know. Cos of a negative angle still equal to the cos of the angle. Why is that? Because in the quadrant diagram, if you rotate up here, you're going in the quadrant where cos is positive this way. There's a positive angle if you rotate this way. Zoom it up. Rotate that way, it's a positive angle. And if you come down here, you rotate negative angle. What does that mean with the negative angle? Is that it's taking it into the quadrant where cos is positive. That is why. That's why the cos of a negative angle is still a positive value. Because it's taking you into the negative angle, is taking you right into the quadrant where cos is negative, where cos is positive. So the cos of a negative angle or the cos of the same positive angle. All right, so that is why, just in case you want to know why everything can be connected in a closed loop. All right, this question now. This question says the modulus of P is 24. OP is what? So this guy just want to know which one of them I give you a modulus of 24 now. That's all. That's all I know. Which one of them give you a modulus of 24? That is all I know. That is all. I'm going to try this one. So this one, the modulus would be the square root of 6 squared plus 6 squared plus 3 squared. Let's work out that if that equals thing here. Because I square this 2, you know. and say which one of them is sum of the square of these equal the square of this. But we can just work it out and see which one of them equal 24, and that is the answer. All right. Can't be none of these, because there's some big number, and then there's some big number. I think the first one, then a big two. Those are some big numbers. So let's get the calculator. Let's see which one it is. Which one it is? I think it's the first one. I'm going to do the square root of 6 squared is 36. And then 6 squared again is another 36. And then 9. I'll get negative 9 for that. Get 9. What? So it's not the first one. All right, so let's try the second one. Try the second one. The first one. So the second one is going to be 16 squared. 16 squared plus another 16 squared. The second one then plus 8 squared. Yeah, so the second one. So this one will give us the answer. This one will give us 9. We'll have to work out. This is not it. This is not it. All right, so it's not it. So we can just work the second one and show that the second one is it. So this is a question you basically just work out. And look at the size of the values and more too, you know. I see them numbers here, them kind of in the same range of that in terms of size. Like them are gone too big. This alone bigger than the 24. And so on, but no matter still. So we're gonna write that the square root of 16 squared plus 16 squared plus 8 squared is actually equal to 24. And so we can take this one and say that is it, 24. All right, in any case, that is the answer, the second one. One of them questions, basically, let's try the values. Let's see which one works. I'm at what, number 27, feeling sleepy. I'm sure I think we can pick up the pace. Feeling sleepy now. This one says a circle that, you know, has a center of -1, 1, and the equation of a tangent to the circle at the point. So this point is the C value. This is the y-axis and the tangent. You know, this is a C equal -3. You know, and between these 2 points, we're gonna get the gradient of the normal. So the gradient of the normal between those 2 points, right? Between those 2 points, right? So it is this y value minus this y value, which is -3 minus a -1 over 0 minus -1 over 0 minus -1. So this becomes a 1 under here. And this is -3 plus 1, which is -2. So therefore, the gradient of a tangent is a half, which is -1 over the gradient of a normal, which becomes negative reciprocal of 2 is a half. That's the gradient. And we have the y-axis intercept. So it happens that the point of tangency is y-axis intercept. So it is y equals gradient of a tangent x plus c, which is y equals half x minus 3. Half x minus 3. This is the answer right here. All right, number 28. Let's pick up the pace. It says a curve is given by the parametric equation that was a Cartesian equation. Same thing again. You want to generate sine squared plus cos squared. So from this one, the sine theta is x over 4. And from this one, cos theta is y over 3. I would know say sine squared theta plus cos squared theta equals 1. Right? So it becomes boom, bang, boom, bang, it becomes x over 4 squared plus y over 3 squared equals 1. So which are those answers we could work out? plus multiply by the smaller, take it out of the way. The smaller that we did down here, shift it over to the right and shift it over here. So we can't do fun. Let's make it smaller first. It's smaller. Electronic cannot say it will be on the paper, that's the same. All right, and then come back to this now. So this is the same as x squared over 16 plus y squared over 9 equals 1. So we need to multiply through by product of these two, right? Which is 1/4. This is 1/4. Yeah, because it's 3 times 4 and 3 times 4, which is 12 times 12, right? 1/4. So I'm going to multiply by 16 times 9. So we multiply by 16 times 9. This becomes 9x squared. That 16 cancel. This becomes 16y squared. And then 9 cancel. And this becomes 1/4. That's 16 times 9 is 1/4. So the answer is 1 with 9 squared plus 16y squared. 16y squared. Answer is C. Right? When you have to reach 30. Oh, it's the only thing we're going. I just remember we're going 45 questions. So not so bad. So we reach number 29. The vector equation of a line through these 2 points is R equals 1. So basically you need the vector AB for the direction. These are the direction components. You need the vector AB, right? So the AB vector, right, zoom up and right here. So the vector AB, the direction, the AB is gonna be this minus 3 in the negative 2 there, so negative 2 there. So yep. This minus this, so you're gonna get minus 2i. Then this minus this, you're gonna get minus 5j. And this minus this, you're gonna get 13. 6 and 7 is 13. You get plus 13k. That's your direction vector right here. All right, and then you want a point on the line. This is a point on the line right here. So this one is your A, the OA. This is the OA. This is the OA. The OA vector. Point on the plane plus lambda. And then this is your direction vector AB. This is the direction vector AB. So the last one is the answer. The last one is the answer right here. Because of those things. That's it. All right. That is it. AB is a direction vector. All right, next one. General solution of this. Now, general solution of a cost. Let's write it down. You need to know them, you know. You can write them anyway. Put this over here. So that's the general solution. Put this over here. So the answer is there. Shift back this on here. I'm gonna write out the 3 general solutions under here, so everybody should know. So it might take so long, you know, I'm still teaching. The general solution, sine theta equals some value k. Then theta equals 2 parts. All right, like so. It equals sine to the minus 1 of the k plus 2n pi, or pi minus sine to the minus 1 of the k plus 2n pi, where n is an integer value. Of cos theta equals k, then theta equals plus or minus cos to the minus 1 of k plus 2n pi. Again, the n is an integer. Right. The n is an integer. N is an integer. And then the tan one now. Tan. So if tan theta equals k, then theta equals tan to the minus 1 of the k. You're going halfway across the circle. Two quadrants that carry the same sign are pi across the circle. So you're going to add just n pi alone, where n is an integer. Those are general solutions. So for this one now, where is it? For this one now, this will be equal to that. So this is a k. This is a k now. Because yeah, this and this equal, right? Because of pi by 3, that is 60 is a half. So you could say that this equals a half. So the general solution is that 2 theta would be plus or minus cos to the minus 1 of a half. It's going to give back that anyway, plus 2n pi, where the n is an integer. So if you divide you by the 2 now, you're going to get theta equals, divide you by the 2, you're going to get, well, cos to minus 1 of a half is a pi by 3, right? So you're going to get, the might go first. So 2 theta becomes plus or minus pi by 3 plus 2n pi. So I'm known from here, so this equal plus or minus that. But this is the answer. This is the principal angle. Right? And then now divide by the 2. So theta equals plus or minus pi by 6 plus n pi. N is an integer. Pi by 6 plus n pi. Pi by 6 plus n pi. Pi by 6 plus or minus pi by 6 plus n pi. The answer is right here. Divide by the 2. All right, that's what it gets. 30. All right, 15 more to go. All right, differentiation now. So this is the differentiate this using the quotient rule. Start with the bottom and end with the bottom square. All right, so I'm going to start with the bottom and end with the bottom square. So my dy by dx is right on the bottom first, which is 2x plus 1. And differentiate the top, and differentiate the top, you get 3. And do it the other way now, but you're going to subtract first. So you minus the top now, right on the top now, which is a 3x plus 1. And you differentiate the bottom, you get 2. And then put everything over the bottom square, which is 2x plus 1 squared. So I guess I'm simplified on the answer based on those. So I will simplify this down, eh? So it becomes equal to, expand out this first, we're going to get 6x plus 3. And then remember, this minus is going to make everything in this a negative now. So it's 2 times the 3x first, the 6x, so negative 6x. And then 2 times the 1 is 2, but the negative again, minus 2 over still a perfect square of 2x plus 1 squared. And then this now reduces to the 6x here, I put a 6x here. Then the 3 minus 2 is 1. So we're going to get 1 over 2x plus 1 squared, which is right in front of us here. That is it. That is the answer. All right, 31. All right, 32 now. Finishing up. This one says the gradient at x equal pi by 6 of the curve. So first we're gonna grade, the gradient becomes dy by dx. I'm gonna take this and differentiate. All right, take that and differentiate it. So the gradient is dy by dx. That's a gradient which is equal to cos x. And so it becomes equal to the cos of pi by 6. Pi by 6 is 30 degrees. Cos of 30 degrees is root 3 over 2. Root 3 over 2. just fell off with a different pen. Hold on a second. You can continue writing. Still writing. Don't want to tap the stopper. Anyway, so equals, right? And the cos of, as I said, this is root 3 over 2, right? Cos of 30 degrees is 30 degrees. Root 3 over 2. Don't need a calculator for them to examine most times, you know. Once you know these things, and I was going to give you stuff that you should know. We have this now differentiated twice. This means you have to differentiate it twice, right? All right, so let me zoom in so we can have space to work. So firstly, dy by dx is going to be, differentiate this, I'm going to get 3 which is 9x squared. Differentiate this now. First I have to differentiate the 5x. Then I know that when I differentiate the cos, it's going to become negative. So this becomes a plus. So it becomes plus. And then the 5 times, of course, 20. And then the differential of a cos 5x is actually sine 5x. I put the negative already. That's what I have first. I differentiate it again. So d2y by dx squared now is, this becomes 18x plus. Again, I have to differentiate the 5x and get 5. 5 times 20 is 100. And then I differentiate the sine 5x is really cos 5x. So this is the answer whereby that is. The last one. Last one is the answer right here. All right, is that. Next one. The dial on a plane preparing for landing, register the number this, where h is the height above the ground. Just as the plane lands, the dial reads what? Just as the plane lands, the h, the height, the h is tending to 0. So the h tends to 0. This thing tends to 1. As h tends to 0, so as h tends to 0, right? Sine h over h tends to 1. Therefore, this tends to register, tends to, we can call it the value tends to 200 plus 5 times 1, which is 205. It says right here. All right? Whatever that reading is, tends to 205. That's it. This always 10 to 1 as h tends to 0. And just as it lands, the height is tending to 0. Just as it lands. See? Just as it lands, the height, h, height above the ground, will tend to 0. And so this formula will tend to 1. That is the question. 35. We're going to have like about 10 left. We're doing the limit as h. The limit as x tends to 1. So as x tends to 1, the x is not equal to 1. It's tending to 1. So x minus 1 is not equal to 0. So it means that we can factorize out x minus 1 on numerator and denominator and divide it out because it's not 0. So the numerator, I'm going to look for the x minus 1 inside. It becomes the limit as x tends to 1 off. I already know. So I'm looking for x minus 1 in it. Let's write it down from now. So the other factor has to be x minus 2, which is correct. Over, I'm looking for x minus 1 in the denominator as well. So the other factor has to be x minus 3, which again is correct. So these ones cancel each other, removing what is creating the problem, and then I can apply the 1 here and there. And apply the 1, it then becomes equal to 1 minus 2 over 1 minus 3, which becomes negative 1 over negative 2, which becomes half. Half is right here. 1 minus 2 and 1 minus 3. Yeah, that's it. Next one. says, which of the following functions is discontinuous? So the one, these are fractions, that's a fraction. All right. These two can be discontinuous too, you know. But the fraction become discontinuous when the denominator equals 0. All right. So this one, you're gonna see the denominator can be 0. X cubed plus 1 equals 0. That's when it becomes discontinuous. And it can, because it can create the cube root of -1. Right? X equals the cube root of -1, which is equal to -1. So that one can become 0. So I can mark that as my answer. This one will become discontinuous when x is -1. I can put -1 under here. -1 plus 1 is going to be 0. You can't divide by 0. So the function will become discontinuous at x equals -1. What about this one? Fact of the matter is that this squared value cannot be negative. So this can never be 0. This under here can never be 0. This expression under here can never be 0. That's right, never be 0. It's always greater than 0. It's greater than 0. This expression under here is always positive, because this will always be positive. The x squared will always be positive. So that denominator value will always, in fact, it will always be greater than 1. Always be greater than 1. It's greater than 1 at all times, because this can only be 0 or more under there. The squared term, can only be greater than or equal to 0. All right. So therefore, that expression is never discontinuous. This one again can only be positive. So under here can only be positive. This can only be greater than or equal to 9 under there. Because the x squared again is always positive, 0 or positive. So this one now kind of be doubtful, because when x, for example, is 10, it becomes 9 minus 100, which is a square root of a negative number, which you can't find. So I'm going to put a question mark on this one. I don't know. But this one really should be undefined as well, discontinuous as well. But it all depends on how them define the domain, right? It all depends on how they define the domain. I think this should not have been on the paper, because it becomes discontinuous when the x is basically when the x squared is greater than 9. Like for example, when the x squared is 16, it becomes a negative number, so they have to define square root of a negative number. Right? So yeah, that one have a question mark on it. But I will leave this as my answer first one. I know that for sure. All right, it's continuous on a graph. This one depends on the domain. This one is discontinuous at x equals -1. And so then we are specifying a value up here, you know. It's a problem. Anyway, 37. It says the radius of a circle is increasing at a rate. The radius is increasing at a rate. The connectivity of changing. What it's telling us is that dr by dt, that's the radius, increasing at a rate. Dr by dt equals 0.1. All right, we don't say centimeters per second. All right, centimeters per second. At the instant when the radius is 3, the rate of increase of the area is. So we need a relationship for the area. So I'm going to draw the circle. We know that the area is pi r squared. The radius is changing, you know. So dA by dr becomes 2 pi r. If we multiply by the 2. All right. And what I want us to find, the rate of increase of the area. So that's asking us for dA by dt. And this is when the r equals 3, right? So dA by dt is the product of 2 rates of change. Which 2? dA goes on top of the first one to set it up. This is equal. Right. So dA goes on top of the first fraction, and dt goes on the denominator of the second one. That's how we set up the chain rule. And the third variable that is there is the R. So dr goes here and the dr goes there. I see that this value really is this. All right. So we need to find out this one from here. All right. So the dA by dt becomes 2 pi r times 0.1. What I say is when the r equals 3. So when r equals 3, so you can write it when the r equals 3, the dA by dt will be 2 pi times 3, 2 pi times 3, 2 pi times 3 times 0.1. 0.1. 0.1 is the dr by dt. That's it. Let's see what this works out to know. This is 0.1 or 1 over 10. 1 over 10. I'm going to put 1 over 10 for the 0.1, right? 1 over 10. So this into this goes 5 times. It becomes 3 over 5 pi. It becomes 3 over 5 pi. Right? 3 over 5 pi is this right here. Number 38. Coming up to the end now. Coming up to the end. It says curve, given that curve has a gradient when x equals minus 1. So the gradient of has a gradient of 0 when x equals minus 1. If a is a constant, what is a? A equals, so the gradient is dy by dx. This can tell us that the gradient dy by dx is 0 when x equals minus 1. So what is the gradient function? Dy by dx is a gradient function. It becomes 6ax squared when we differentiate this. We're going to get plus 10ax. Differentiate this, we get plus 20. Right? And this equals 0. Equals 0 when x equals -1. So let's zoom this up. Let's zoom this up. Make this smaller with some space. No space to write. So when when x equals -1, this expression, I put -1 in it, equals 0. And so you're gonna get 6, put the 1 in there. 6a times -1 squared plus 10a times -1 plus 20. Then say it is equal to 0. Now this becomes, this is 6a, step by step. This is 6 times a. -1 squared is positive, right? This is just 6a, just the same. Then this is going to be minus 10a. And that minus 10a plus 20 equals 0. This right here, so now is -4a. -4a plus 20 equals 0. Carry over the 4a and divide by the 4. So the a equals that over divided by the 4. A equals 5. 20 over 4. A equals 5. I'm getting sleepy now, guys. I'm getting sleepy. See if I can wake up myself. I'm tired. 6 more questions to go. This one says, in 2012, price of petrol was $2.31, while in 2019 the price is $33.71. What was the average rate of change of petrol for the period? So basically it's gradient, and average rate is gradient. Right? So it's like you have the points. So yeah, like you have the base 2021, that's like your X value, 2022, sorry, 2012, I mean, and you have the Y value of 231, 2.31, 1 point. Another point is 2019, and you have a value of 3.71. All right, and then the rate now, the rate of change, rate of change equals the gradient in the 2 points. The rate of change we're trying to find, right? Equal the gradient. So the gradient, what is the gradient? Difference in y over the difference in x. So it becomes rate of change becomes equal to 3.71 minus 2.31 over 2019 minus 2012. And that's what we're working out. Calculator. My brain is tired and tattered. This becomes a fraction. 3.71 minus 2.31 divided by 2019 minus 7 years. Okay, 0.2. This right here. Yep. 14. Last 5. 40, 41, 42, 43, 44, 45, 40. 40 says, closes. 40 says, give us this diagram, and it's a curve, likewise x into 4 minus x, and the axis, x-axis, and the line x equals 5. All right, it said the total area of the region A and B is, all right, so the area under here is going to come out negative under here, so it's going to come out negative. So to show the true value and add it up to another area, you have a negative, you have to take the negative of it. Or you have a modulus it, take the modulus of it. So the area is going to come out negative. All right, if you work it out normally, but to get it back positive, now you modulus it. So it becomes the area under here, so which is between 0 and 4. And then the negative area under here, so between 4 and 5. So that's what you're looking for. And let me see this one. So between 0 and 4 on the first graph, yeah. And then now, as I say, you are adding this area. It becomes a modulus. You're adding between 4 and 5. Adding between 4. But if you integrate this straight, they're going to come out negative. If you modulus it. So this is the answer. This is the first part. It's both between 0 and 4. There between 0 and 4, the A, and then between 4 and 5, the little graph. Right, just to make sure, you know, because they're the same graph, but it's between 0 and 5 because negative with modulus on it, right? Modulus on it. You there, still, Brandon? Are you going to sleep?
No, I'm there, man. I'm tired too.
Yeah, you want to sleep. All right. We mash up that one quick. Let's 4 to go. All right. So I want to integrate this, right? I'm going to give us this as an identity. This is x over 4. So I'm going to make some adjustments to it. All right. So from this, you don't want to see. From this, you don't want to see where the sign of square of x over 4 is. So I'm going to make some adjustment on this right here. First adjustment that you want x over 4. So I'm going to change this to x over 4. So if this becomes x over 4, then this x becomes x over 4. So this becomes x over 2. That's the first thing. Then notice do have a 2 in front of it. So if I'm going to divide this 2, it's going to become half, and it's going to get a half. So what is going to happen is that based on that, the sine squared x puts in a different color. Sine squared x. Tired. All right, this sine squared of x over 4. That's what this I'm making this a subject now. It's gonna become a half minus half of this as well. And this works out to be x over 2. This works out to be x over 2. So from the cos of x over 2. And so if you're integrating this, you're integrating that. Guess what now? The integral of a half, integral of a half is half x, you know? Integral of a constant. So basically you're integrating both sides. So you integrate this side, integrate all of this side. All right? Dx, or then. So the integral of a half is half x, so then it becomes equal to half x. Let's integrate this minus the integral of half x. We can put the half outside. Multiplying constant. We can put the half outside. Integral of cos x over 2 dx. And then you add your constant. So you can put that answer right there. Which is the second one. B. They don't put no constant enough. They should put a constant. But they don't, but you know. So not B, because we have a 4 in here. So it's actually A, right? Answer A. But check the answer them careful, right? Because time they look close, you know, the same and it's something different. So check carefully. It's for the 1, for the 2. So the rate of change of y with respect to x is this. Then what is y? No, this right here is dy by dx. This is dy by dx. No? Dy by dx is that. So the basically telling us. So y becomes the integral of 3x squared plus, and this now becomes 4x to the minus 3 dx. And you're ready to integrate now. So it becomes equal to, add 1 to this power divided by new, I'm going to get x cubed. X cubed there, yeah, this and this. Which one of them it is? Then they're going to add 1 to this power. You're going to get negative 2. And when I divide by negative 2, they're going to get plus 4x to the minus 2 over negative 2. And then add a constant. And then we're done, because you're going to get x cubed. It's going to become minus 2 over x squared. This negative 4 means just because you're going to get minus 2 over x squared plus c. So it's x cubed plus minus 2 over x squared minus 2 x squared. Inside this one. I want to sleep. I'm tired. I'm tired. Number 43. I'm doing this for Jordan in Tobago. This one says portion of a curve y equals 2x between A and B is rotated 360 degrees, which is 2 pi radians about the x-axis. The volume V of solid can be best represented as one. So this is y now. And the volume, remember now, is pi times the integral of y squared dx. And go between A and B. So the y squared now is this squared. So it is pi times the integral of 2x squared. So y squared is 4x squared. If you square this, I want to put 4x squared dx. So that's what you're integrating. Pi times 4x squared dx. 4x squared. This one, I know, we'll put pi inside and the 4 side. The same thing. No, this is dy. Wow. Dx over 1. See that? Bang. So the 4 is there. We put a pi on the inside. But that is it. All right. Next one is number 44. Penultimate. Let's hope that there is the last set. It says h is equal to this, and I want h prime. Differentiate. The composite enough. So h prime is a blue. h prime of x equals, differentiate first as if it is x cubed. So it will become 3 into x to the 4th power plus 2 times squared, with the power 2. Then differentiate what's inside here times, it's going to give us 4x cubed. So we're going to get in differentiate it one time. Let's consolidate. So when I get 12x cubed into x to the 4th plus 2 squared, 12x cubed. So 12x cubed and 12x cubed there. There's one with the square root, right? Sure. Yes, one with the square. We support by a 1. That's the answer. We'll come to the last question on this paper. All right. And it wants us to work that out. That's what the answer is. Remember, you have to also divide by that. But the integral of cos is sine. The differential of sine is cos. So this is going to be 2 sine 5x. We're going to divide by the differential of 5 over 5. And going between pi by 2 and 0. You can use a calculator, remember, you know. You can use a calculator and get the answer. So it becomes equal to 2 sine of 5 pi by 2. Put this as the x over 5 minus, and plug in the 0 there and get 0. So whatever this work out to know is the answer. We can work it out still now because this is what? This is 2.5 pi. This is 2.5 pi. It becomes 2 times sine of 2.5 pi. 2.5 pi. 2.5 pi. We can write it. 2.5 pi. I can write it this way. It's 2 pi plus pi by 2. Over 5. Slick. That's 2.5, all right? You see that 2 pi there, so you say, because sine of pi by 2 over there, and then you go a full revolution around the circle. So we will come back to the sine of pi by 2. It's still equal to 2 times the sine of pi by 2 over 5. Sine of pi by 2 is 1. Then it becomes equal to 2 over 5. Which is right here. Bang! End of this test. Soft with a capital T. Yeah, 1 or 2 nice questions in there. That is it. So I'll share the video online. All right. Share the video. That's it in a jar. Brandon. These people for Jordan. Jordan asked me to be fine.
Oh, God, sir. I mean, the paper not really seem that bad, you know. I just need to go over some trigger identities and just revisit some concepts. By Monday, I'm good.
Yeah, when is the exam?
Believe it's Monday, the 19th.
Monday? Oh.
Yeah.
Okay, all right. I'll put in some work between now and then. Just binge your paper them, man. Yeah. Run the binge on them. All right, cool. We end it now, yeah?
Yeah, yes, sir. Miss GC, going to post this video online?
Yeah, man. We're going to post it and send it.
All right, thank you.
Yeah, man. Cool. Ending it now. All right, Jordan. So this video is for you as well. All right, cool. All right. Oh, by the way, anybody who get onto this video and who are interested in classes, my number is 876-881-5600. All right. My name is Rafik. So each private class, yeah. private textbooks for exams. CSEC, ADMAT, and Pure Maths, particular Pure Maths Unit 1. All right. Yep. You can reach out and you can subscribe on the channel if you like the content, so that each time I post videos you can get it, or you can like and share the video. Not a problem. All right. Cool.